Hi everybody, my name is Pete Fine and welcome to the August edition of the Pittsburgh Python Meetup. If you don't know, we're here at Code and Supply, which is a community co-working space. This space, takes money to run. If you're not a member yet, please consider joining and continuing to make it so that we have a place that we can do events like this. Tonight's talk is about Python. Oh gosh, I'm sorry, dude, I forgot the name of your talk. Such a great talk. Static analysis tools, type annotations, basically different ways you can use tools you can integrate into your workflow that operate on your code itself and help you kind of produce better quality code. We have or I guess a tradition at this point. How many months does it take to make a tradition? Two it is. We have a tradition here of doing a little bit of warm up. What I like to call the module of the month, just going through a quick demo of a helpful module in the Python standard library or outside it. This is based on a really nice site called Python Module of the Week, which is the standard library by example. If you're not familiar with it, check it out. Tonight's one actually doesn't come from that. Is a new feature in Python 3.7 called import lib resources. Import lib resources solves like this long-standing problem in Python packaging of what do you do with the things that are not Python code. So you have an image, maybe it's like your sample teapot image that you want to do processing on, or you have a text file that's got a list of all the cities and states in the U.S. That's not really Python code, but maybe you want to load it up into a dictionary, you kind of parse those bytes out, but it really wants to live with your code. And this has been something that's been painful and difficult in Python for like a surprisingly long time. And in 3.7, there's this new import lib resources module that helps you deal with that. So it's got a really, really very, very simple API. If you've written code before, you might have done something like this. Can people see this first example up here? Okay. Pull that back down. Where basically you find out where on the file system the module is you're running it. So if you use this magic_file thing, that'll give you the name, the path and name of the file of that current Python code. And so then you can parse it out using os.path and then encode it back in and say, okay, hey, great, I'm just going to assume this text file lives next to my source code. Good. The downside is this doesn't work so good in a lot of different situations. If your package is bundled up as an egg or a wheel, like basically a zip file, like there's no actual file system, and that file magic doesn't really work right. So there's been like previous attempts to fix this that has not been so awesome. Import lib resources makes this really simple, where it provides a couple of functions: read text, read binary, to get the path of a file if you would just actually need an actual thing on disk. And this will work across zip files, this is across wheels. And all you have to do is, let me find if I can find the nice example here. Is you package your stuff up, is if it's got a knit file, like a Python package, import lib resources can deal with it. So basically it lets you stuff things directly in your regular package hierarchy. Does that make sense to people? And it's really not very different than what we've been doing before, except that there's a standard way.
Consume the file when you want to use it. How do you ship it?
Oh, that's a great question, and that is a question that is, thank you for this lead-in, that we'll be dealing with next month at our September Python meetup, Pittsburgh Python meetup, which is going to be a panel discussion about packaging and distribution of Python code. So that question actually is also it's better but still painful. It's sort of if you make something, how do you? So the questions we're going to be answering in more like a panel format is like, how do you package something up to put it on PyPy? And then how do you do kind of more esoteric things like include data files, which is packaging still painful. Things like pipenv, people are probably just getting familiar with pip. And now we have a whole new thing that is better and more awesome, and you have to start using stuff like that. Yep. How do you what best practices for packaging stuff with Docker? I'm hoping somebody can explain Conda to me because I just have no clue. And I know it's a thing out there. So yeah, if these are kind of topics you'd like to be on a panel, please come find me afterwards. We'll talk about those. October, we're also looking to do another kind of community event, and I'm calling it the New Things in Python 3 Community Lightning Talks. And so getting up here and giving a talk for a half an hour or 45 minutes is hard. And keeping this group going, I really, in the spirit of Code and Supply, I want to make this kind of a community effort. And the hope for the October session is that everybody here can find something new in Python 3 to talk about for 5 minutes. It can be less than 5 minutes. If you go to this meetup page, I'll send this around. There's a spreadsheet here with some topic suggestions. Much like, as people know, like Python 2.7 is going like end of life in 2020, and you're all going to have to start using 3 or be like the Perl 5 or whatever people, and it'll suck. And I think a lot of us have looked at this as a challenge. Oh gosh, I got to port all my code. And as I've started to work with it, there's a lot of things that are positive and things to be excited about. And so that's what I'm hoping that these lightning talks focus on. It's not how do you port from 2 to 3, but more these are new things in 3 that should motivate you to go use it. And so, like I said, like we need to like collectively entertain ourselves, because at some point y'all are going to get bored of me. I'm bored of me. And so, like I said, please consider signing up for one of these talks. There's a bunch of topic suggestions and then links to the what's new pages. Feel free to, if you like these, you like something else, but like 5 minutes, something new, something exciting. And on that positive note, I'm going to hand off to Bartholomew, who's also going to talk about new exciting things in Python 3. Thanks.
Thanks, Pete. So, hello. Real quick, something about me. My name is Bartholomew Elliott. Right now, I'm currently at Bartholomew Tech LLC as a software solutions consultant, contractor. There's my email if you want to email me. Most of my experience has been in a couple different types of technologies. So I have experience in Scala and Python and Ruby on Rails, a couple of different parts of the stack. But I've been writing Python code for maybe 5 or 6 years, maybe 6 or 7 now. That's a little bit about me. I have some questions for you guys. Who writes Python for their day job? Show of hands. Okay, about half. Who writes Python for fun? Could be the same group. Okay, a lot more. Cool. Could also not be the same group. Who uses a text editor to write your Python code? Text editor, not an IDE. Okay? And who uses a IDE like PyCharm? That's an operating system. Okay. All right. Interesting. So that was like half and half, IDE and PyCharm. I just want to, oh yeah, quick outline. I'm going to talk about linters, formatters, and then static type checkers and static type automatic generators, which is a super cool thing. I know it's kind of scandalous for a dynamically typed language like Python, but I'll tell you maybe why you would want to, or when you should want to use static typing. So quick note on PyCharm. PyCharm, an IDE, is basically a text editor with some of these static features built in. So it has a linter built in. It also has kind of a code formatter. Oh yeah, a code formatter with Control-Alt-L. And it also has some on-the-fly type checking in the latest version of PyCharm, but that's super recent. And I think that it's always good, even if you use PyCharm, it's always good to figure out how to use the tools on the command line and what's actually going on behind the scenes. So even if you use PyCharm, you still might learn something today. So quick note on linters. So a linter, at its base, is used to statically run on your Python, on your .pys, basically, to show you what you might be doing wrong. So its output is just suggestions, warnings, errors, or just comments on your code. So it doesn't actually change, right? A linter shouldn't actually change your code. That's what a formatter should do, which we'll get to later. So linters should statically run on your code. It should give you, oh, your imports are out of order if you want to enforce that code style in your code base. So your naming conventions are all out of whack. This doesn't match what you want over here for your function names or variable names or something like that, right? So its output should just be basically a list of all those things. So I'm going to talk about a couple linters, one in specific, but the other popular linters are Flake8, which is just a wrapper around two projects that used to be separated. One is called PyFlakes, and one is called PyCodeStyle. It used to be named PEP8, which is the name of the Python enhancement proposal that, you know, was the first code style basically for Python. But the name, you know, PEP8 is what you would type into your console to run it, and that was kind of confusing for people to match. So they changed the name to PyCodeStyle, but I don't think anybody really uses PyCodeStyle alone. Correct me if I'm wrong, if anybody uses PyCodeStyle, but I think most people use Flake8 if they use any linter. PyChecker is also a common linter, but the most common by far is Pylint. Who here has used Pylint before? Nice, cool. So, super easy to install, as always, pip install. He just taught me about pippin. Now all my slides are out of date. That's okay. So what you do is basically you go into your project and then you, oh right, so the first thing you do is to generate a Pylint RC so that you can change and nitpick exactly what you want to enforce and for your linter to tell you about that you're doing wrong. I'll tell you exactly why you want to do that in a second. I think it's time for a little demo. So, first things first. Oh, apps. So, I have a really simple project. I'll show it to you in Emacs. So, I have two files, coins.py, as you can see on the bottom left. Is this big enough, by the way? Everybody can see it now? Cool. And we have a test.py. So tests, really simple. This is the interface. You get, I'm importing my coins module. I say coins that US dollars, $1 and 0 pennies, get changed from payment of $0 and 99 pennies. And that should raise the assertion insufficient payment exception. So that's the interface. So this is the bad case that you try to get change for an amount that was more than you paid. So you shouldn't get any change from that. Getting negative change would be super cool. Good feature. Anyway, so testing exact payment, blah, blah, blah. So basically all you have to think about here is I'm creating US dollars, and you'll notice that I have a Japanese yen example down here, but it's commented out for now. So that's not being run. So all my tests do is test the US dollar, okay? Let me just show you real fast. Okay, I'll show you that I have a currency class that has all these things on it, constructed in a certain way. Really, all you have to care about is this function, get change for amount, and it does, you know, some logic, tries to figure out exactly the best optimal way of, you know, figuring out change for a project, or for a paid amount and a charged amount. So let me just show you real fast. We have US dollars, which are a subclass of currency, and they basically implement all the things that are unique to the US dollar. So there are 100 pennies and $1. That's what that is supposed to be. It's called the coin to bill multiplier. And then these are all the types of bills. These are all the types of metal coins, right? So paper bills and metal coins. And then I implemented a couple other currencies that implement the same three functions: init, string, and subtract. So that's that. So that's the project that we're going to be working with. So now what I want to show you, I'll show you real fast, that my unit tests work. So they do some stuff, dispensing 0, dispensing, change do 7, should give you a 5 and a 2, 50, a 25, 10, and 3 ones, okay? So they work. So the US dollar works for now. Now let me show you, back to Pylint, what you should be doing if you're getting started with Pylint. So the first thing you should do is to generate an RC file. Note G is an alias for get status. Note that didn't actually add any file. All it did was output all of this stuff, tons and tons and tons of lines. So you should be putting that in a file, and let's look at that file now. So this is why this is the most important first step, because a linter should be telling you exactly what you care about. But by default, linters have everything turned on because they want to show you what it can do. So you need to chop all of this stuff down that it can do into what you care about. I guarantee you don't care about all of these things. Let me try to prove that to you. Pylint, source, change coins. All right, let me tell you all the things. So, thinks my lines are too long. The default is 100. Okay, I agree with that. My lines are a little bit too long. This doesn't conform to my snake case naming style that it assumed that I wanted in that case. The problem comes from PEP8, but maybe I don't want that, right? So maybe I turn that off. Too many arguments. That's interesting. Gotta go figure out what that says. So this linter gives me too many things. Also, it gives me a code rating, by the way, 5.6. Don't look at this. Don't look at this. Let's forget about that. Yeah, machine learning. So the point is, for linters, here's the headline. It's really loud, so quiet it down to get it to tell you exactly what you want. Another quick note. I found a project on GitHub that lets you hook Pylint into Jenkins. So, that's by default. You can hook Pylint and run it on anything in Jenkins. I found a project that lets you hook Pylint into your git commit hook, so that every time you try to commit, it'll run your stuff. Oh, hey, look at all this stuff, and you remember, oh yeah, all that stuff that I tried to write last night. That doesn't really work. So that's that for Pylint. So now we're going to talk about formatters, and in my mind, formatters are the thing that's the next level after linters. Ideally, for me, a formatter should automate the process of, so instead of putting a linter in your git commit hook, instead you would put the formatter in the git commit hook and just let it do all the things that you already care about. So basically, automate the process of, write some code, try to commit, run the linter, yeah, I have to go change this, the linter yelled at me, okay, write some more code, yeah, I forgot about that one, right, there's this process. And if your formatter is very well tuned, ideally you could automate the whole process and not care about the whole cycle. So a couple of popular formatters are Yet Another Python Formatter by Google. It has the most stars on GitHub. I forgot how many, some thousands of stars. And AutoPep8, pretty nice name, I think, from back in the Pep8 days. But the one that I'm going to talk about today is called Black. It's kind of new, actually. It was released 6 months ago, and it already has about half the stars that YAPF does, Google's tool. So that's why I'm going to talk about it, because it's really exciting. So its philosophy is exactly what I tried to say a second ago. I'm going to take control of all of your Python formatting. Just leave that all to me, and then just write code, and then format it, and then commit it. So Black tries to get all of that automated for you. I think you might know what the main issue with Black is, and that would be finely tuning it to do exactly what you want. Let me show you an example. So right now, all we have new is this Pylint RC file. I'm just going to leave that around for now. Let me show you. By the way, you install Black with pip or pipenv if you're the new wave, apparently. Source, change coins. So it did it. And as you can see, it actually did it. Let me just show you real fast. So I undid that change that it did. You can actually do --diff to make it not actually change anything, but instead just output. As you can see, nothing actually changed. Instead, just output what it would have changed. So the diff, as you can see from the plus and minus. But I actually want to do it. Black. And let's look at what the difference. Look at what it came up. So it put all my lines that were too long on new lines. I like that. Cool. What else did it do? Same thing, I think. New line. It converted all my single quotes to double quotes. I'm not too sure about that, actually. So this is another one of the it doesn't know exactly what you want problems. It is also super finely tuned, customizable, and so you should definitely go in there if you're trying to use this tool and look at everything that it has to offer before you just start using it. So, right. So in my mind, the best formatter in the world, you never have to think about. You set it up, you run it every time you commit or every time you probably ever commit, and then you just forget about it entirely. That's not my general experience with formatters from a bunch of different languages. Usually, it changes something that the linter thinks is wrong. So then, when you're trying to commit to Jenkins, the linter yells at you, yells your build, but you ran the formatter and the git commit hook. I've had that happen more than once. Yeah, so that can make you feel like you're at war with your formatter, and that's absolutely not what you want. Like if that's the case, just don't even use a formatter at all. You should definitely feel safe with what your formatter is doing to your code. That's, I think, its main feature. That it's trying to normalize all your code. So imagine you're on a team of 10 developers. You guys all want to have very consistent code style, and that's what this is trying to do. Make that consistent. Yeah. So if it's not doing that for you, you should work harder to make it do that for you. Now, we're going to talk about type annotation generators. So the first one we're going to talk about for just a minute is PyAnnotate. Here we have a couple examples of something you can do in Python 2. So this is one way to do static type comments, not static type hinting. So this is Python 2. This was all the way back in Python 2. You can say that things are certain types in a comment at the end of a line. That's cool, but it's a comment, so it's not really code. I mean, it kind of is code, right? Because your static analyzer acts like it's telling it something about the code, but it's not really code. So PyAnnotate is Dropbox's tool, which is able to generate this kind of type comments. To generate Python's free-style type hinting in actual code is not a feature that it currently supports. It's actually a work in progress, and they're trying to, I don't know how hard they're trying, but they're trying to add that feature soon. So the one that we're going to actually talk about today is called MonkeyType, which is Instagram's tool and does generate Python 3 style type hints directly into your code. It's really cool. I'm going to show you a demo in a second.
So when you say generate, like, what is it doing?
Yes. So, good question. The name of this talk is static tooling, right? So I'm cheating a little bit. You have to run your code, and it's running in the background, and it's going to try to figure out what kind of types things should be, or what it thinks things should be. I'm going to go through an example in a second that hopefully is easier. But you should know, I guess, that it's not technically static because you do have to run your code at some point. And it is getting info from your from the running of your code. So do I want to check this out? Yeah, let's go ahead and get back to where we were. So all we have is this Pylint RC file. You're going to have to forgive my PyEnvious. Yeah. So I'm using PyEnv because just a quick side note. So I'm running Arch, which is a rolling release. So I got Python 3.7, and I was like, yes, Python 3.7. And I'd already written this talk. And then Python 3.7 and MonkeyType did not play well. So I have to. So right now I'm using Python 3.6 to run MonkeyType. There's an open issue on GitHub. It's getting fixed soon. Okay. Yeah, Python 3.6. We were able to run our tests. Everything works fine. So the reason why I ran MonkeyType is that it generated this thing. It's a database of what types it saw in the command that you gave it. So I ran my test, right? And let me just remind you that my test is only US dollars. So I'm not actually doing anything with any other currency other than USD. And it generated some stuff. So I want to actually look and see MonkeyType, see what kind of stubs it thinks. So another quick note. I went back to the command that I ran, which is Python exec MonkeyType. So forget about the first part. Just MonkeyType stub MonkeyType run test.py. So I ran it. That was the first command, and I gave it the file name, the .py. So now when I want to actually look and see what it thinks about my code, I have to talk about the name of the class with the module. So basically slashes versus dots. So now I want to look at source.change.coins. Step. Note, it didn't actually change anything. It just gave me this output. Said, oh, from typing import list and tuple, cool. This is the syntax for Python 3 type hints, the arrow after a function name and a colon after a parameter name. So it thinks that in this function, amount should be US dollar, and it should return a tuple of list int and list int. Interesting. It thinks that cost is an int and paid is an int. Interesting. In the US dollar class, it thinks that other, when I'm trying to subtract, is a US dollar, and it returns a US dollar. That one looks pretty good. Thinks that string returns a string. That looks good. Thinks that a net returns none. I'm okay with that. These up here, though, I'm not so sure about. So note that these are in the currency class, which is the super type. It shouldn't know anything about US dollar. So this is one quick gotcha that you'll get if you try to run you try to run Python 3 type annotation generators. They don't really know what you're doing. So they're guessing. They're giving it their best guess. This is not what should be here, right? This function should know nothing about US dollar ever. So real fast, let me try to fix that. So a quick fix is going to be, oh, okay. So remember that database we generated? Yeah, let's go ahead and try to add a test that adds a different currency. So now when it runs the code, it's going to look into this get change for amount. It's going to look at amount. First in the test, the amount's going to be a US dollar, US dollar, US dollar, da da da, and then it's going to be a JPY, Japanese yen. Let's see what it does in that case. So let me check out my, oh, I didn't actually run it. Yeah, let's do that first. So the command I did was stub. It's this command, and all that does is output something. So now what we want to do is MonkeyType, apply that stub, actually do it. So this, again, this module in this class, actually this module, coins, and it did it. Let's look at what it did. It basically did exactly what we saw the stub was going to say it was doing. Cents is an int, dollars is an int. I'm kind of okay with that, right? Sub for the dollar class up here, yeah, class USD is, oh, there's a dollar, that's a dollar. So all this is kind of cool, except it fails my unit tests because of exactly the problem that I was trying to say earlier. The error that it gives is that US dollar is not defined, or USD is not defined. That's because now, actually I need to look at this function again. So now, after we applied the stub, it put all this in, and it's referencing US dollar here, USD here, which is above where I defined USD. So that's the main problem, that it figured out my class structure, then it didn't really know which order. Like, it didn't think too hard about the order that it was being generated in. So let's kill this again, actually. Let's check that out. Let's remove this so that we don't have any of those types anymore. And then let's, right, I already changed the test, and now I'm going to save that file. So now we're going to be running JPY in our tests. And then now I'm going to do the same exec again. So in our output of the test, you can see that our yin test is now being run. Now we're going to do the same apply. Let's just go ahead and straight apply without looking at the stub. And now let's look at what it did. Here. So it didn't get any smarter, really. It just tried harder, right? That's a common problem that you're going to find with this kind of tooling. And so,
sorry, quick question. A union type would be, it's like one or the other?
Right. It's the set of both of those are able to be that type. So actually, let's look at and see if it did anything else differently.
So there's a typing library in the standard library now?
Yep, in Python 3.
That's where union would come from?
Yes.
Yeah, let me. Yep, it's up here.
There it is.
Actually, the version of 3 is in the library. A version 4, you just have to install it with typing.
It's in the standard library.
Oh, no, typing.
Yeah. So, yeah, it's trying harder. So, back to the slide here. This is basically the process that you would do to try to figure out or to try to generate Python 3 type hints. The common pitfall that's linked here, as you can see in the URL, it's called forward references, and that's exactly the problem that we're hitting now. It's even in the pip itself, or PEP itself, because they knew that it was going to be such a common problem. The way, if you go to this link, the way that they suggest solving this problem is, instead of, so right now it's just calling a class, which is union, which as we saw is from the typing library. The solution in this case is to not actually use this class. Instead, you can say in a string a class's name. And that's exactly what we need to do in this case. So let me look for any other unions. Okay, so I wanted to do it in this function too. I'll go and replace this.
Those things are all spelled with square brackets? Like,
which one?
You're like, yeah.
Mm-hmm.
What?
Do some Googling.
Okay.
Yeah.
Generics? Is that what this is?
I think so. No?
I think they're generic.
Right, because you can put in whatever types you want.
The point is some sort of containerish thing, and what it can contain is the.
Right. So in this case, it was trying to contain my subclasses. Oh, right. Why don't we, instead of just doing a union, silly me, why don't we just do a currency, right? Because that's what it's trying to be. The union of JPY and USD. Yeah. And then if I write another test with Great British Pound or right? Really what we want it to be is a currency, right? Get changed from another currency. So I'm going to leave this one as a string, and I'm going to put this one as the actual type that I have. And now we're going to run our tests again. Name currency is not defined. Oh, line 40. Let's go to line 40. It's this one. So the problem is the currency is like a correct class, but you can't refer to the class that you're defining a function within, right?
Busted.
Yeah. Busted indeed. So that's why I jumped straight to the quotes, but I forgot what they call this, but it's basically going to do this last. So it's going to do all your, figure out all the classes. Okay, now let me try to figure out what those quotes were that it skipped over earlier.
What namespace is used in dereference?
Good question. Moving on.
Come back next month.
I don't have a good answer. You should look at this PEP. I'm sure it's in here. 0484.
But MonkeyType doesn't have enough brains to say like, oh, I've got a union of 3 subtypes. Maybe I'll look
yeah, let's look up a little bit.
No.
That
If you have like 30 classes, would it have like a list of union of 30 things?
Could we write a generator for something that would have a list of 30 classes?
You could. Right. So that's kind of my takeaway from this tool, MonkeyType tool. I don't know what PyAnnotate does. I wonder how it would solve this problem, or how it will solve this problem once they add Python 3 style type annotations. But I can't imagine that it would be very difficult to try to be smarter.
What's the use case for this tooling? You want to take a code base that doesn't have type annotations and add type annotations to it?
Yeah.
Okay.
But that's not as easy as running a program. That's also the second takeaway, right? You have to babysit this process because, it's running your code. It's trying to figure out what your code is wanting to do, but it doesn't know.
But you're going to do that once for a larger project, and then you're not going to run it continuously as you add more code, right? You're going to be manually adding type hints.
Right, writing code that has type hints in mind,
okay,
right?
So this is for
that's the
retrofitting
ideal.
Type hints onto.
Exactly right. So like a 2 to 3 tool, this is a 2 to 3 typing tool, kind of. At least it's trying to be.
So I've been doing Python a long time. I have never used it, and I've seen almost no code that actually does use it. Like why? Like what do we? Okay, we've got the hints. What do we do with it?
Well, it should make your code base more readable, right?
I don't know. I don't know. It looks less readable to me.
Less readable?
Yeah, man. Yeah. Like go up the top where like I don't know, like that structure.
I thought we had 100
I
line.
use it and it revealed bugs in my code just from when the types revealed that I was messing up where I was passing around. And so even without much tooling, you could get some basics there. And then various IDEs, development environments, and like can actually use it for sensible type completion.
Right.
I just use it for Exeter. So
type completion is a big use case. I know PyCharm just added some type completion stuff.
Yeah, it's already like even when I did stuff for my internship, like it already was catching certain things like this is returning something and you're not using it properly. I'm like, oh. And it just came out just when I just started putting types in everywhere.
Yeah. So type. What did you? Yeah. Go ahead.
Oh, this is the next topic.
Okay. Go ahead.
Python 3.7 solved that future stuff with the type hints, but they buried it behind a feature import.
Okay.
So from Python 3.7 onwards, you use from feature import annotations, and a lot of the problems you went through disappear.
Okay, awesome.
What is
So
it
the forward references are gone?
It defers the evaluation with AST manipulation.
Hmm. Oh, repeating that so briefly, Python 3.7, which just was released, basically destroys my whole talk. No, it solves exactly the forward reference problem that I was showing here with the quote, having to do this nonsense to talk about a thing that hasn't been defined yet by doing some AST manipulation. Awesome.
But you have to use a feature import because otherwise it breaks backwards compatibility.
Ah, repeating that, you have to use a feature import because it breaks backwards compatibility. Awesome. Thank you for that. I just have a couple more things. Let's get through that and then we'll get to some questions, okay? Just a few more. I could go through the process. Who wants to see me go through the process of actually changing to all the quotes? Okay, that's what I thought. So I can go through and I can kill all these forward references. The other ones are down here in the sub classes because they also haven't been defined while they're being defined. So you have to replace all these with quotes. And then all my tests will pass again.
What if you try that future import right now? Or this is 3.6.
I'm on 3.6 because MonkeyType doesn't work with 3.7. I also wouldn't have done it. No way. Live coding is dangerous. Okay.
It's just pair program.
Pair.
Mass pair program.
Mass pair. Okay. So Mypy. Oh, I should go to the slide. So that was all about MonkeyType. So now actually to the static type checker. So just a reminder, that was type annotation generators. So running your code, trying to tell you, and put into your source code, oh, I think these are the types that you wanted. So now back to static type checkers, which are less involved. Basically, quick note on which ones are the big ones right now. Right now, Pyre is Facebook's tool. It's only 3 months or 4 months old at this point. Not totally mature, but there is a lot of support. So definitely check that out if you're interested. The one that I'm going to talk about is Dropbox's tool, which was put into the standard Python GitHub repo called Mypy. It's really, really simple. So you just Mypy on your .py, and it'll tell you what it thinks your problems are. So quickly, it's kind of like in the same realm of a linter, right? It's trying to tell you, hey, I think you should probably look at this stuff. So it's not going to change anything for you. So it's basically linters and static type checkers, and then there's formatters and static type generators. So in this case, it's just telling you what it thinks might be wrong, which is one of the main use cases for typing, along with real-time type, suggestions. Oh, I think this type is this, or dot, and then it auto-completes your sources. That's the second, I think, main use case for typing. So in this case, Mypy told me, oh, look at line 44 and 45. There's an unsupported minus sign. Okay, let's look at that. 44 and 45. So it thinks this payment minus self is weird. That's interesting. Let's look at what payment is, and let's look at what self is. Payment's a currency. Self is supposed to be a currency. So I think this is another forward reference problem, which hopefully is solved by Python 3.7 future. Yeah, so that's Mypy. It just gives you an output, tells you, hey, I think this is wrong. So that's it. Here are some references on the slides. And now, get back to some questions. Yeah, go ahead.
So I haven't worked with these type hints at all. Do they change the way that your code functions, or are they out for other tools?
Right. It's only for other tooling. It's not actually going to change how anything works. It's just kind of on the meta level of trying to show, right? So you can use it for, like I said, for maybe an IDE is trying to, in real time, give you a dot and then auto completion of, oh, these are all the things that are on the object that I know is of this class, right? Of the currency class. I know it has a right? All these functions. And so that's the main use case. Other than that, they're not really used. I think Does anybody know the answer to this actually? Does Python 3.5, 6, or 7, does anything just take all the type hints out when it tries to interpret it? I'm not sure about that.
I mean, it doesn't do anything at runtime.
Right, it doesn't do anything, so I assume they might chop it off, or maybe they just ignore it.
Yeah, just it's there.
Just sits there. Okay.
There's a bit,
Yeah. Go
there's a
ahead.
bit of complexity in loading all the stuff in at runtime, which is the rationale for another bit of the change in 3.7 feature import, so that it brings back a bunch of performance which we dropped. So if you're in a thing where the startup time for Python matters, then you really want to go to 3.7 on the future import.
Interesting.
That same future import also does that.
Do any of the documentation tools have like annotation awareness? Like, I mean, this looks not very different than what we've been writing in Sphinx doc strings for a while. You know,
Mhm.
add arg, right?
Yeah.
Exactly. Add arg int, and
Mhm.
like, I gotta type this a second place now, or will that, or just like do those tools?
Sphinx caught up.
I don't know the answer to that. That's a really good question. So I would imagine that somebody is smart enough to not have you duplicate it, right? Does anybody know the answer to that question? No?
All right.
I would imagine somebody is smart enough to look at the other one, right?
Okay.
One hopes. Yeah.
When you have code with forward references,
Uh-huh.
should you sort of take a step back and think about whether you should restructure your code?
Well, in this case, like talking about a US dollar, you know, I want to be able to subtract a US dollar from US dollar,
Okay,
right?
fair enough. Yep, fair enough. Okay, fair enough.
There are some cases that make sense. I totally agree with you. There are some cases that it doesn't, right? Yeah. More questions?
Basically. Yes, take a step back, make sure it's right. If it is, proceed.
Yeah.
I guess like two comments maybe. Just first one is about someone asked him like, what's the point of all this? You know, why do you want static types in Python? And one simple example is like just option type, right? Checking for none. You know, it's like none errors and all pointer thing. You know, that you can, if you're have code that's type annotated, calling code that's type annotated, you can check to whether you know whether there's a chance you forgot to check for none somewhere. You know, when you're just doing anything like that. So it's pretty common exception. The other comment I was going to say is like I use both Mypy and Pylint, and one advantage of Mypy is that it's faster for like large files. You know, it's a separate question whether we're making our files too large in our code base, but you know, it might take Pylint might hang if you're trying to see every warning possible in a 1,000, 3,000 line file, and it's like Mypy will just run instantly, pretty much. So that's another like why use both. It's they have different trade-offs.
Cool. I have a couple questions for you. Okay, who's excited about static typing now? Who's gonna go home and use it? Yeah? You're gonna try it?
Yeah, maybe.
Wow. I didn't expect that.
I didn't expect that either.
Awesome. Cool. Any other questions? Yeah.
Yeah, is anybody using this? Like, open source projects, personal projects, work projects, does anybody like actually use this stuff on a day-to-day basis?
Yes.
1,
Okay.
2, 3, 4.
And is this, in what like work, open source, like, or on work?
Client.
Which is open source.
Okay.
Python has something for client.
All right.
I know that, I mean, I don't code, I really came to see static analysis tools in action or, some practice going around them, but I support a distributed database written in Java, and I know that, if we start to look at surface exposure, class exposure, what fields are actually accessible, we've found, just huge amounts of things that we didn't really expect. And I mean, that happens. We've drawn a lot of OSS software together under one, big thing, so that probably, stands to be expected a little bit. But I think if you take even any one of those projects, and because really what we're talking about is not defining static types, right? We are talking about annotating classes that you've made with more information about what they expose. So when I think about that, what I'm really seeing that there is we're not going to change anything about what Python does. What we're going to change is our knowledge of potential side effects in our own code. And that's really that, right? Like you said, non-exception. Unexpected no pointer. Trying to multiply a letter by a number. Stuff like that. And, you know, you can do that. It'll come out one way or the other, depending on how you do it. But at least this way you kind of have visibility into that. And I'm thinking there's probably some advantage in maybe bigger teams where you aren't the only fingers in the project every day.
Right.
Outside consultants, things like that. Or to pave the way for those guys, maybe. If you have somebody that you've contracted to turn out factory code, you really want to set them up with it. As much insulation as possible from any sharp edges. So.
As much, you know, metadata, like surrounding data about what you think they should be doing, right?
Yeah, right.
Yeah.
Yeah, what you expect.
What you expect.
Right.
I don't know, I guess just the people who have used it, like, tell me a bug it's caught. Like if it's actually
None types, right? I imagine that's a
None types, couple of, yeah, so. Yeah, none types, I mean, it's like, it points out, like, just, I mean, it makes you think about your code, like, should you have, you know, what you know, at least makes you think about types, I guess. Maybe, I mean, if you're maybe a traditional Python programmer, it's like you came to Python to not worry about types, but, you know, if you want to kind of adopt that to some extent, you can at least see, okay, what, you know, if you read, if you don't have method names, you know, with parameters clearly defined, you know, just making that clearer. It's like you said, it's in the comments, but you can also just have it, you know, checked a little more explicitly with Mypy.
At least one team I worked on used a static checker, actually, Rubicop for Ruby. It's sort of social engineering as much as software engineering, just to establish a baseline that everybody needs to hit and like self-arguments over code style. So if it runs cleanly in the static checker, then you know, if it doesn't run cleanly, then if everybody agrees, well, we've got to make it run cleanly, then you don't get into big arguments during code review.
Interesting. So you're using it as a tool, right? You care about its output, and you care that everybody cares about its output, basically. Interesting. Yeah.
And it runs in continuous integration.
I mean, does like Mypy have enough brains to understand like type changes and branches? Like if you have a defensive if not none, return, you know, we're just done, right? Like, and then you're actually going to run some stuff. Will it have enough brains to know that, hey, I'm past that, that, you know, if I'm past that point in that function, like it can't be none here. Does it have that? I mean, does it have that kind of smarts yet? Or
good question. Mypy is more, I think, mature than the generators.
Didn't Dropbox hire Guido to work on Mypy?
Basically.
So you know, it's pretty far along.
Okay.
So I don't know the answer directly to that question, but I imagine that it's
okay.
Yeah. I mean, that's a pretty simple thing, right? Well, maybe not simple to implement, but simple to reason about. You know, you should not care if it's this if I already checked if it's not that, right?
Yeah.
Especially none, which is a big use case.
This is a lot like writing a compiler.
Yeah.
Yeah. Right. I mean, like you have a type, like in a type language, like C or Rust or anything like that. You have a type checking phase where you do this, except your program will compile. Okay.
Yeah. Don't worry. Don't worry. This is a dynamically typed language.
Okay. And I continue to just like code cowboy if you want to. Huh?
If you want to, sure.
Okay.
Worst case, annotate with any, and then it's fine. It doesn't matter what the case is.
Yeah.
Any. Yeah, just put any everywhere.
Can you do template? When you do like template types, like that's one of the things I'm actually interested in using it for. Is where like I have like really generic code, like it's sort of a generic generic functions on containers. And I don't, it's a list of strings, it's a list of integers, it's a list of boobars. I don't really care. Right. Well, but I want to say like. the any, you know, on the right side needs to be the same type as the any on the left side. It's not really any type.
Right.
It's more
A
like,
T.
It's like, yeah, it's like C++ T.
Right.
Sorry, I said that. But yeah, I mean, can you do that kind of like, I don't even know what to call it, like
Generics, right?
generic type?
Right.
It's like a name.
Yeah, the generics are there,
Yeah.
Okay.
or you can make your own.
Okay.
Easily so.
Right.
All right.
Any other
I'll let you
comments?
know how it goes.
questions? Yeah.
Yeah.
Me personally. Am
Yeah.
I responsible now?
Yeah.
Any other questions?
Details.
All right. Oh, one last one.
Are you gonna put this up for us to look at at home?
Sure. I should put it on SlideShare.
SlideShare is always good.
Okay. Can we send a meetup?
Yeah, you can
Message?
send it to the people who came here.
Okay, cool. I'll do that. I'll send. Does anyone want this silly project? Okay, I'll send it. I'll zip it up.
Sweet. So just, I know folks, there's like 2 meetup groups still we have. Like there's the Code and Supply subgroup, and then there's Python group. We're just kind of still trying things. Send it to both. If you
Okay.
want to join, like the Python. We have broad coverage.
That's the positive.
We're using some adjusted papers and pens here meetup features. But anyway, we're just trying. But please, if you're not a member of the Python specific group, try to join. We'll make sure we get this out to you.
All right. I think that's it, guys.